Good morning, depending on where you are watching me from. Tonight we are going to be talking about the two-dimensional coordinate system in trig and analytical geometry. Is that clear? Please don't forget to take the attendance after 10 minutes. Is that clear? And share the link in your group WhatsApp so that others may join without finding it difficult. So tonight I'll be talking about the two-dimensional coordinate systems in trig and analytical geometry. Is that clear? Are you following? Okay. So the two-dimensional coordinate system or systems, rather, there are two ways that one can position a point in a plane. Is that clear? There are two ways that one can position a point in a plane. And that is what we want to look at, the two-dimensional coordinate system. I'm going to explain it to your own understanding. Is that clear? Are you following? Okay. So, there are two ways. There are two ways that we can position a point, a man, in a plane. There are two ways. When we say plane, it's not really mean the flying plane. Is that clear? We are talking about mathematics. When we say plane, plane could be in this form. So here we have 0. We have this is the origin, and this is x-axis. This is y-axis, and this is x-axis. Two of us. But when it's beyond this side, this x-axis is always positive, and y-axis is positive. From here up is positive, from here down is positive. But anything down to the left, this side is always negative, then while this other side is always negative. Is that clear? So, when you come across something of this form, mathematically we refer it as what? Plane. That is what I mean, not the flying plane. Is that clear? Okay. So now I said there are two ways that we can position a point in a plane. So what are those two ways? One is Cartesian coordinate system. One is Cartesian coordinate system, that is of this form. So it is always in the form x, y. So whenever you come across anything of this form, note that it is a Cartesian coordinate system, x, y. Do you understand? Are you following? Do you understand? Are you following? Okay. So, if you are following, it means when you come across something of this form, it is in a Cartesian coordinate system. Then, look at it. We have y and x. So, as it is in Cartesian coordinate system. Is that clear? So now, 2. Let's consider 2 is a polar coordinate system. It means polar coordinate system, we are talking about r, theta. Is that clear? So whenever you come across something of this form, note that it is in polar coordinate system. Now, why am I doing all this? Because we are going to convert from Cartesian system to polar system. We also convert from polar system to Cartesian system. That is how to convert. We look at all those things. Any question? Do you have any question? Do you have any question? Please share the link. Share the link. So far, so good. So, in polar coordinate system, let us have a right angle triangle. Let's have it in this form. Okay. The right angle triangle. This is O, P. Let us name here M. So here is our X. Then here is Y, right? Then here is R. True of us. So as it is, let us try to use Pythagoras theorem to obtain our R, since this is a right angle triangle. Is that clear? You don't need a prophet to tell you. Here, note that here is opposite, and here is adjacent, true of us. Then here is hypotenuse. So you go back to the laws of Pythagoras theorem, true of us. It states that the square of the longest side is equal to the sum of the square of the two remaining sides, true of us. So this implies that r square will be equal to x square plus y square. Then our r will now, because if you take square root on both sides, you are going to have x square plus y square. Do you understand? Are you following? Hope you are following. Do you understand? Okay. So far, so good. So, you are following, right? So now, this is our arrow. So whenever we are asked to find or transform it in polar form, we need to obtain our arrow and theta. But from trigonometrical ratios, our tan theta is equals to what? Let's apply. I don't want you people to cram, so let us apply SOHCAHTOA here. SOHCAHTOA, right? So tan TOA is equals to tan theta, two of us. So it means tan theta is equals to opposite. O means opposite, then A means what? Adjacent. So coming here, what is opposite is Y. Y. Then what is your adjacent is X, right? So far so good. So this implies that our tan theta is equals to Y all over X. So how do we obtain our theta? We obtain our theta from here by dividing through tan. So it means by the time we divide through tan, we are going to have theta is equals to tan inverse. Tan inverse of Y all over X. Any question before we proceed? Because we'll be using all this to solve problem examples. Do you have any question? Any question? Any question so far? Do you have any question, please? No question? No question? Okay? If there is no question, let's proceed. Let's proceed, right? Okay, yeah. So, we are going to solve some problems here. Change Cartesian coordinates into polar coordinates. Change the Cartesian coordinates. Example. Change the polar, talking about Cartesian coordinates. That is 3, 4 into polar coordinates. Okay. Yeah. This is as simple as ABC. We are going to look at this example. Is that clear? From changing it from Cartesian coordinates to polar coordinates. So now let us write solution and have the diagram. You know, I mentioned it to you that the Cartesian coordinate is x, y, true or false. So let us have a diagram, a plane diagram. Then we have this. This is the origin, theta, rectangle, triangle. Exactly. Here is x, it means they said we should convert, that is, change the Cartesian coordinates into polar coordinates. So what we need to do here is, polar coordinates has r, theta, two of us. So it means we are going to look for the value of r, also look for the value of theta. So for us to look for the value of r and theta, I told you that r is given as r equals to what? Square root of x squared plus y squared, two of us. The y tan theta, that is theta, is equals to tan inverse of y comma x, isn't it? Okay, so if you agree with me, let's come here. Don't need the prophet to tell you. Here, this is x, so here we have 3 here. So x is 3 here. So instead of x here, we change it to 3. Then here we have y. Then here we have 4. So instead of y, we are going to write what? 4 here. True or false? Are you following? Do you understand? Any question? Hope you are following. So what we need here is, let's obtain our r by using this formula. So our r will now be equals to x is, your x is 3, where, okay, let me write it out, where x equals to 3 and y equals to 4. So our r will now be equals to square root of 3 squared plus 4 squared. Then r is equals to, r is equals to, note that when we have 3 squared, this is the same as 3 times 3, and 4 squared is the same as 4 times 4, which is 9, which is what? 16. True or false? It's true, right? So here we are going to have 9 plus 16. So our r will now be equals to 9 plus 16 is 25. And 25 is a perfect square. True or false? So square root of 25. Square root of 25 is 5. Any question at this point? Before we move further to look for the value of theta. Do you have any question? Do you have any question? Any question so far? Do you have any question? Any question? Okay, no question. So we can proceed to consider tan, that is theta. So it means our r comma theta will now be equals to, r is what? We are able to obtain r as well, 5. Okay, so let us find theta. So for us to find theta, we make use of tan. Where theta is given as tan inverse of y all over x. So where your y is what? Tan inverse. Y is given as what? 4 all over x is 3. True or false? So press your calculator to give us the right answer. So it means tan inverse, we are going to have 53.1 degree, right? 3.13 degrees. So therefore our theta is given as 53.13 degree. Do you have any question at this point? Please. Let me give you guys 1 minute to ask your question before we proceed further. Any questions so far? Do you have any question? Any question? Yes or no? Do you have any question? So this is how to change the Cartesian coordinates into polar coordinates. If there is no question, let's proceed to solve more examples. Let's proceed to solve more examples. Okay, express in polar coordinates the position example. In polar coordinates, the position minus 4,3. Yeah, it's simple as ABC minus 4,3. Minus 4,3. Okay, so far so good. So let us consider this example. Writing solution. Let us have a plane. Okay. This is the origin. Yeah. You know very well that, I told you guys that here is plus, here is x plus, here is minus, excuse me, and here is minus x, true or false? So look at this position. The position of x is a negative side, true or false? So let us have it in the negative axis. So let us assume your point P, 0, M. So 4. Already it is not necessary we put minus. Please take note. Minus 1, because already it is in the negative as is not necessary. Is that clear? So you have to be smart and take note. Supposing here is minus 2, y is minus, we would have our rectangle triangle here. So please take note. This is theta. Yeah. So our y, since it's positive now, so y is positive, so it's going up. Supposing it's negative, you have come down. But for the fact that x is negative, that is why you are seeing it immediately after the 0 this side. That's why we have the rectangle triangle here. So our y is what? 3. So let us obtain our arrow since expressed in polar coordinates, the position. Are you following? Do you understand? So what we need to do is our arrow is equals to square root of x squared plus y squared, right? So therefore, where our x is equals to minus 4 and y is equals to 3. Amen? Okay. So far so good. Our arrow will now be equals to square root of open bracket minus 4 all the square plus 3. Right? All the square. Then this is going to give us 16 plus 9. Our arrow is equals to square root of 25. Which is arrow is equals to what? 5. Do you understand? Any question? Please drop it in the comment section. If you have any question, drop it in the comment section. Okay. So that is that. Then let us move further to consider our theta. Our theta is equals to tan inverse of y all over x. But mind you, our x is the negative, so the angle will now turn. True or false? The angle will now turn. The angle will now turn. So let us have this one as here. Let us assume here is phi and here is theta. So the angle will now move to the negative side. So whatever angle you obtain from here, you subtract it from 180 degree. So what we need to do here is theta will now be equals to tan inverse of 3 all over 4. Then tan inverse of 3 all over 4 will going to give us 36.87 degree, 36.87 degree approximately. So now our theta, our angle now, this will now be subtracted from 180 because of the it moved towards the negative axis. That is 180. Is that clear? That is to obtain this. So here we are going to have our theta will now be equals to 180 minus 36.87. So if you do press your calculator, you are going to have 143.13 degree. So theta is going to be 143.13 degree. So you can now see that since they said expressed in polar coordinates the position, so therefore the polar coordinate is r comma theta, then this is equals to, what is your r? R is 5, then theta is 143.13 degree. So this is how you are going to solve this type of problem. So now we are able to solve two problems from Cartesian coordinates to polar coordinates. So now let's look at from polar coordinates to Cartesian coordinates. That is what we want to look at now. Any question? Do you have any question? Do you have any question? No question? So now we look at changing from polar coordinates to Cartesian coordinates. Okay, the first example, two examples we have solved. That one is changing from Cartesian coordinates to polar coordinates. And this one I want to look at changing from polar coordinates to Cartesian coordinates. That is what we want to look at. It's simple as ABC. It is not difficult. Okay, let us go back to our elementary trig identity. Let's recall SOHCAHTOA. Amen. SOHCAHTOA, right? Let's recall SOHCAHTOA. Yeah. Then let us have our rectangle triangle again. Let's have it this way. This is R, this is Y, X, theta, rectangle triangle, Y, X, the origin. Okay? So now you and I will know that this is a hypotenuse opposite adjacent, right? So sin, that is so, is equals to sin theta. This is equals to O means opposite, H means hypotenuse. Two of us. Then this is equals to opposite is y all over hypotenuse is r, right? So this implies that our sin theta is equals to y all over r. So if now we are asked to want to find the value of y, because we are Coming from polar coordinates to Cartesian. I told you Cartesian is always x comma what? Y, true or false. So if you want to find the value of y, it means we need to cross multiply. It implies that y is equals to r sin theta. True or false? True or false? Y is equals to r sin theta. Okay. The same thing. This is what we are going to use to obtain y. Then the same thing applicable here. Car is equals to cos theta, right? Where A is adjacent all over H is hypotenuse. True or false? This is equals to adjacent is x all over r, right? So this implies that our cos theta is equals to x all over r. Since we are to transform it into what? Cartesian coordinates, so we need to obtain our x. So by the time we cross multiply, our x will now be equals to r cos theta. So this is the formula you will use in finding your y and x. Any question? Please, if you have any question, drop it in the comment section. Before we begin to solve examples, any question so far? Do you have any question? No question? No question. Okay? There is no question. Let us proceed to solve examples. Change example. Change 4, 32 degree into Cartesian coordinates. As simple as ABC into Cartesian coordinates. Okay? So what we need to do, we write solution, right? Okay? So now you don't need a prophet to tell you. Already, it is a polar coordinate system. In the polar coordinate system is 4, 32 degree, which is equals to what? R, what? Theta, right? So this implies that your arrow, where r is equals to 4, and theta is equals to 32 degree, right? So now, how can we obtain our x and y? By using this. You don't need the prophet to tell you. So to obtain our x will now be equals to r cos theta. Then our x will now be equals to, what is our r? R is 4 times cos theta. That is, theta is 32 degree, right? So cos 32 degree. Then in your calculator, press cos 32 degree. Then at the end of the day, you are going to have 3.39. Therefore, x is equals to 3.39. Then let us consider y. Do you have any question before we proceed to consider y? Any question? Gentlemen and ladies, do you have any question, please? Do you have any question? No question? Okay. Okay. Then let's proceed to consider y. So y will now be equals to r sin theta. Then y is equals to r is 4 times theta is 32 degrees, sine 32 degrees. So your y will now be y is equals to 2.12. Is that clear? So in the coordinate or Cartesian coordinate system, this is how it will be. That is x comma y is equals to 3.39 comma 2.12. So this is how to convert from polar coordinates to Cartesian coordinates. Gentlemen and ladies, we are going to stop here, call it a day. But please don't forget to comment and share, like and share it on your social media platform. Thank you and God bless you. See you next time. I love you guys. Bye.